Hey everyone, welcome back to the Data Engineering Fundamentals series. In this video, we'll explore the world of data pipelines. What exactly are they? Why are they essential? How do they work? What are the different types? Let's kick it off. What exactly is a data pipeline? Imagine a city. All the water is scattered around in reservoirs, rivers, and wells. That's your data. A data pipeline is like a complex system of pipes that takes the raw water, filters it, pumps it, and delivers it to your taps, clean and ready for use. In a sense, data pipeline automates the flow of data from various sources to where it needs to be. Just like a city's water pipeline, it extracts data, cleanses it, transforms it, and deliver it to a usable destination for analysis. In the data lifecycle, it covers the stages from collect to process to store. Why is this essential in data engineering? Data pipelines are essential because they automate the flow of data from various sources to where it needs to be. This means no more manually copying and pasting data, which saves you tons of time and reduces errors. Plus, pipelines ensure your data is clean, consistent, and ready for powerful analytics. How does a data pipeline work? Just like a water pipeline moves water from the reservoir into your taps, a data pipeline includes a series of steps, each of which delivers an output that is the input to the next step. It extracts data from various sources, cleanses it by removing impurities, transforms it by changing the format, and delivers it to a usable destination ready for analysis. Let's dissect this further and understand what each part of a data pipeline does. Data source. This is where your data originates. It could be databases, websites, social media feeds, sensors, external APIs, or logs. Anything that generates information. Data processing engine. This is the core component responsible for treating the water. Here, the data is cleaned by removing duplicates and errors, transformed by converting formats, and enriched by adding data from other sources. Imagine a water treatment plant filtering, adjusting pressure, and maybe even adding minerals. Next component, data storage. Finally, the prepared data arrives at its destination. Processed data is stored in various locations like reservoirs and water towers. These could be a data warehouse, a central repository for historical data analysis, or a data lake, a more flexible storage option supporting various data formats, an analytics engine where you can analyze the data and gain insights is also an option. This is like delivering clean water to your home. By the way, if you want to dig deeper into databases, data warehouses, and data lakes and the supporting technologies, watch out for the video in the data warehousing series. Data orchestration. These are the unseen forces that keep the water flowing smoothly. Data orchestration ensures each step within the automated data flow happens in the correct order. Some popular tools include Apache Airflow, Azure Data Factory, AWS Glue, and Prefect. Data monitoring and logging. One critical aspect we should not overlook is monitoring and logging. It's vital to monitor our data pipelines to ensure they are performing as expected. Just as a utility company would monitor water pressure and quality, we must track data flow, watch for any signs of leakage, and maintain logs for auditing and troubleshooting purposes. This helps us quickly identify and resolve issues, ensuring the data remains pristine and the delivery system remains robust. Supporting technologies such as ELK Stack, Elasticsearch, Logstash, and Kibana, Splunk, Prometheus, and Grafana can be invaluable. These tools provide real time insights, comprehensive dashboards, alerting mechanisms, and in depth analysis capabilities, making the oversight of data pipelines more effective and less cumbersome. There are different types of data pipelines depending on your needs: batch pipelines, stream pipelines, and hybrid pipelines. If you have already watched the video on batch processing and stream processing, I'm sure you're wondering what the difference between these two. As I said before, these pipelines automate the data flow, meaning batch pipelines automate batch processing, where they accumulate a significant amount of data and then process it all at once. These are ideal for processing large data sets periodically, like daily or weekly sales reports. On the other hand, stream pipelines automate stream processing, where they process data continuously as it arrives, making them ideal for real time analytics. This is useful for situations like stock prices or social media feeds, where you need up to the minute insights. If you are curious to learn more about batch and stream processing, I highly recommend watching the video. Circling back, there is another type called hybrid pipelines. Sometimes you need to accommodate both. A hybrid pipeline combines batch and streaming approaches to handle different data needs. Building a data pipeline involves planning these steps, just like designing an efficient water delivery system. You define what data to collect, how to clean it, and where to send it. Data pipelines play a crucial role in making data usable and powerful. By understanding their components and applications, you're taking a big step towards becoming a data engineering pro. No matter your role in the data world, data quality engineer, data analyst, or if you are a data analytics student, understanding data pipelines is essential for success in your role. If you have any questions about data pipelines, please leave them in the comments below. Happy learning!